Thank you very much. And hello to everybody from around the world. And thank you very much for spending your time contributing to this discussion. So I guess I sort of want to start with drivers, really. You know, what are the drivers for this? Why are we talking about carbon neutrality? And just to sort of frame it a bit, and then we're going to start talking about frameworks and measurement systems and some examples as well. I think there's this really magic moment where we've got the attention of world leaders on sustainability and climate change, particularly on the built environment. You can't solve climate change without solving cities, and you can't look at you can't look at technical solutions in isolation from all the other drivers. We've got this wall of money looking to invest in green buildings, whether they're new build or refurbishment. I think something like a fifth of all the FTSE 100 listed companies in London now have committed to net zero carbon in one form or another. And we have trillions of dollars of assets under management, all aiming towards net zero. We've got investors, developers, asset owners, and corporate occupiers. So enormous pressure from investors looking to invest in green buildings. We've also got increasing demand from occupiers of buildings, whether they're commercial tenants, residents in cities at all tenures of buildings. And arguably the COVID-19 pandemic has just emphasized how critical it is to have buildings and cities that are healthy, clean, environmentally responsible. And there's really been a paradigm shift, I think, in people's understanding of the importance of the built environment in creating the kinds of spaces that support life and that support our ecosystem. And so this mixture of the top down and the bottom up is providing a real push to the market for all professionals, including architects and engineers. Buro Happold is one of many that have now declared a climate and biodiversity emergency. We've published our goals in our global sustainability report, which you can find on our website. And I'm just going to pull out 3 of our headline targets here, which are relevant to this project, this presentation. One of them is to be net zero carbon for our own business operations. We've set science-based targets in line with the Science-Based Targets Initiative to drive down the operational energy and operational carbon of our practice. And that includes reducing the energy consumption in our offices, but critically reducing the amount of carbon we use for business travel and commuter travel. The second is to design all our new build projects to be net zero carbon in operation from 2030. And that's in line with the World Green Building Council and many other corporate targets. And the big circle here is for our new target that we set at the beginning of this year as well, which is to reduce the embodied carbon intensity of all new buildings, major retrofits and infrastructure projects by 50% by 2030. And that's quite stretching, but in line with some of our leading clients. It's in line with C40 cities and World Green Building Council again. So that's a challenge for all of us on this call today, is how are we going to achieve 50% reduction by 2030 and beyond that? How do we get to net zero and ultimately absolute zero, perhaps by 2040? So I'm going to start by talking through some of the frameworks for measuring whole life carbon, embodied carbon and net zero. And these terms do get used a bit interchangeably. So I'm going to try and describe the differences between those for those of you that are less familiar with this. There's also a wealth of resources out there which you can go and read if you haven't already, and many task groups, industry leadership task groups around the world, particularly through the Green Building Councils. And they're a fantastic way to understand, to contribute, and to build relationships with your clients at the same time and your collaborators. I'm going to pull out one of them here, which is from the UK Green Building Council. So this is the Net Zero Carbon Buildings Framework Definition document, which we contributed to as part of the Advancing Net Zero programme. And so if you want to know about net zero in the built environment, I think this is a really good place to start. Each country around the world has a slightly different framework to reflect the specific regulatory environment in each country, but they're all following the same principles, which are set by the World GBC. So there's 2 parts to this to understand. One is that this is partly about operational energy for heating, lighting, ventilating, cooling buildings. It's also about the embodied carbon in construction. So the carbon used to extract materials, to process materials, to transport them, to manufacture, etc. So first of all, you've got to be clear about what's included and whether it includes both. You've got to reduce your construction impacts by doing life cycle assessments and thinking about how to reduce the embodied carbon in construction, to reduce the operational energy use through good low energy design, both of the building and the building services equipment, making sure that your building ultimately try to hit certain good quality benchmarks for energy consumption and embodied carbon, and then making sure that your building is ready to be powered by clean green energy through a mixture of on-site renewable energy and off-site renewable energy. And we'll talk about that in a bit more, but enabling your building, for example, to be running on electric, using electric heat pumps powered by wind farms, as well as on-site renewable energy generation from, for example, solar roofs. Then it's to really, once you've worked your way through that hierarchy, sometimes there is some residual carbon impact, and then it's about offsetting that carbon impact through an established, verified, well-established carbon offsetting scheme, and disclosing performance on an annual basis. So this is all about real world. It's not just about predictions. It's about real world impacts to get to net zero carbon. One of the key things to understand as well is this term whole life carbon. So it's not just thinking about design, it's thinking about the product production, it's about the building process, it's also about the operation, and also about the end of use of the building. Going back to Emanuela's question about circularity, it's also about how do you take apart a building? How can you reuse the components? How can we ensure that most building products have a second life? Almost thinking as buildings as material banks, with a set of components that you can take apart and reuse again, another place or another building. There's a very complex set of frameworks that have been developed, and this diagram tries to show some of those as well. And so when we talk about whole life carbon, particularly talking about that dashed blue box, and it includes the embodied carbon and the end of life stage and the operational carbon all together as one. The embodied carbon includes, say, all the areas at the beginning around the product stage, the construction stage, and the in-use stage. And then the operational carbon is about the operational energy and also the carbon impacts of water. Whereas the end of life stage and the circular economy stage tends to be thought about a little bit less, but is very important as well. This diagram tried to show the fact that this is a very fast moving agenda, and I'm sure you all recognize that even in your own countries, there's a proliferation of lots of different standards out there. There's, so taking a UK example, we have city policies from the Greater London Authority, which is probably the most advanced city in this space around this agenda in the UK, but many other cities now moving fast as well. We have reporting through environmental impact assessments. There are targets from UK Green Building Council, the London Energy Transformation Initiative, LETI, the professional institutions like the Royal Institute of British Architects, and also the certification schemes like BREEAM and LEED. And they all measure slightly different things. So that's not helpful, we understand that, but it's very important that you're very clear about, you know, what is it you're looking at, what's most important for your project. And we're slowly but surely getting alignment now. So clients asking for the same thing in the same format, and the industry's learning together. So for operation, we can conceive about how we get to net zero. So it's about measuring, it's about having high levels of energy efficiency, local renewable energy, and enabling your building to be powered by clean green energy, often clean electricity, but could be hydrogen systems or low carbon heat, zero carbon heat from heat networks. And then having a very clear carbon accounting and carbon offsetting for residual carbon. As I say, for embodied carbon, it's a little bit harder. So Thomas is going to talk through a little bit of around the targets now, and I'll hand over to Thomas, and then I'll drop again at the end.
Yeah, perfect. Thanks so much. So there is many frameworks out there, and also all the architecture boards around do understand that they need to act on it. So there is from Rivers that we find quite helpful in our international project, the challenge on domestic and non-domestic buildings and how by time those can be brought into play. So also one of the questions that came in on really how do we get there, what are benchmarks? So that helps us quite a lot on looking at benchmarks where we want to go, and also seeing that it increases in a 5-year period. Next one, please. On that one, it's kind of important. I tried to see that the question, how can you realistically offset it? So offsetting is one of the topics that was on Duncan's slide, and maybe we take it for later on. So on big question is where the embodied carbon is in, and there you can see that much is in construction already, 35, sometimes it says 40%, And then we do have it in maintenance and refurbishment. So there is really for everyone, there's something in there and something to act on with operations and regulated and unregulated as well. So that leading to the next part, where it's then on where can we act on it. So from the construction part, what we're mainly talking about it right now, it's mostly in superstructure, facades, MEP, substructure, fit out, but also the transport and construction. In reality, you need to tackle all of them. It's not really helping out to only tackle one, because the impact won't be significant. So you probably have to go on all sides, and we're going to show you on a few projects also then where we did that. Next one. So that also means looking at it from over the whole period of the design life, but then also from the beginning. So first of all, the question you always need to ask is that whether a building can be reused, whether you can bring in changes that make it possible to have it in for the next generations, or whether it has to be new build. So that's a question we bring in quite often to our projects. The second one is that you need to challenge the brief, especially as an architect. You need to ask really, why do you want to achieve certain topics, and also is it already ambitious enough? And that's one of the biggest questions we get on projects. Are our ambitions right? Could we do more, or should we do more? And the third one is then really bringing in low embodied carbon in your materials. Often enough, and we're going to see that as an example, it's a mix of materials, so it's not going only for one material on 100% of the building, but it's a mix. But then when that's normally when we come in, and it's very important as an architect to bring in efficiency in design, and to design what's really needed, and to see on what aspects are to be considered most. And then last but not least, design for deconstruction. That's a tough one, especially for the architecture, to say, well, we build it in a way that in 1, 2, or 10 generations, it has to be taken apart, and how do we best do that? Next one. And so that's then the questions that are coming up then. How does good look like? What is a benchmark project? And how would you actually define it like that? And one best in class that's currently on site, and just last week we had the roof getting on top of the building. It's a hybrid building, so we have timber structure in there, we have concrete in there, we have a lot of smartness in it. It's also aiming for certification. It goes for DGMB, platinum, it goes for WELL gold, and quite a lot of effort. It's a very interesting site. It's a pre-used site, and it does have a lot of components. If we go to the next one, so from the rendering, really bringing it alive, one of the key parts is open space, bringing light in there, and we have those trees in there that serve as meeting facilities. And you can see already here that we have a mix of materials. So there is a hybrid. So obviously there's quite some concrete in there, especially below ground structures. But also here you can see that the trees do require in the bridges certain materials, but it's mostly concrete in it. And then we have a lot of timber, as you can see from the frames, but also from the roof structure with ETFE for it. So there is really a mixture of material, using the right material for the right purpose. And here we see it in construction already bringing in modular elements, prefab and precast. That's one of the key parts, and on how those things can become successful. And the next one already shows you a bit of the underside from an office floor. So very interesting to bring that in. It's a full BIM model behind it, and that has been brought in from the early design to construction. Here it's also just everything that was taking place on site has been tested before. Everything has been played in a modular way, and so that makes the whole construction process quite fast and very good to calculate the effect.
I'm going to show another example now, which is another project which is on site at the moment, which is the Stratford Waterfront development in London on the Olympic Park. And this image is from probably the biggest building on the site, which is the London College of Fashion, which is relocating from about 3 or 4 different buildings across London, all onto one site for the first time. So it's part of the University of the Arts London, and sits alongside, it's part of a culture and education district alongside the Victorian Albert Museum, V&A East, plus the BBC Concert Studios, Sadler's Wells Theatre, and also some residential schemes as well. And I mean, I just want to show this example because it's it's a very high quality design. So Allies and Morrison, the designers for this LCF building, you know, and there's no compromise on quality, and yet it's been designed very carefully with both passive design and active design to be very low energy demand, low embodied carbon, connected into low carbon energy networks, but also climate resilient. So making sure that the scheme, the building is robust in terms of the environmental conditions for the future. So we've been testing the climate out to 2050 and beyond to think, well, how is this building going to work in a much warmer climate? So it's a mixed mode building with a mixture of natural ventilation and mechanical ventilation, high thermal capacity through concrete, but also making sure that we're reducing the embodied carbon of that concrete where we are using it. Solar PV generation connected into a site-wide heat and power network run by an energy services company. 25% of the heat comes from wood chip biomass, the rest currently from gas-fired combined heat and power, but with a plan to decarbonize the heat network in the future to be hopefully zero carbon. Again, part of our workflow has been very important, working with the architects. I think this building on the image actually is for Vienna East, which is the building next door, but we did this for all the buildings on the site. This one was with ODT architects, but essentially having to take the three Revit models, the architect's model, the structural engineers model, and the MEP engineers model, using coding and scripting to connect those together, using one-click LCA in this example as the embodied carbon database, and then running lots of analysis, lots of optioneering to understand what the embodied carbon could be. We're also fortunate that we had a very strong client, London Legacy Development Corporation, who even several years ago was setting embodied carbon reduction targets for us as a design team. And through using this analysis, we're able to kind of find the hotspots, if you like where can we make biggest impact. So this was showing, again, for those same categories we were talking about before, what are the most contributing material types to the embodied carbon footprint? And you can see it's mostly steel and concrete, and particular structural steel profiles, and ready-mix concrete for structures. So that's where we really had to focus to have the biggest impact. But through good design and very careful thinking about column grids, cement replacement, PFA, all sorts of different, working through aggregation of marginal gains, we were able to make some really big reductions. And on the operational energy side of things, we also been thinking very carefully about operational energy. So this is a very complicated graph for those that don't normally look at this, but we're looking at what are the existing buildings doing where they are at the moment, because this is quite a unique building, because you've got a mixture of teaching spaces, workshops, laboratories. It's a really quite interesting mix of activities in a space. So it doesn't easily lend itself to, for example, an office energy consumption benchmark. But here we compared it against some existing buildings, which are quite simple but older, like London, the old London College of Fashion. We compared it to Central St Martin's up at Granary Square and King's Cross, but also the new London College of Communications building. And so through that, we're able to work out, how low we could go, which turned out to be quite low. So the net result of that is a building which is on site at the moment, which we're expecting to meet and beat the RIBA embodied carbon target of 600. It's actually very close to another target from Letty, which is 500. So we're really pleased that if that through the construction process we managed to achieve that, that's going to be a real exemplar of how possible it is to get actually close to a 50% reduction compared with standard benchmarks, which may be up to 1,000 kilograms of CO2 per square meter. The total energy consumption, I say it's a bit higher than an office, which would be aiming for about 160 nowadays, but it's a lot lower than most labs, and you saw much, much lower than existing buildings. So this is an example which has been now included on the New London Architecture Zero Carbon London case study examples. So both of those examples show what's possible to do to drive down energy consumption, to reduce the embodied carbon of construction. As I say, this is also connected into a site-wide heat and power system, which has a roadmap to zero carbon as well. And so through the combination of those two, we expect it to have a pathway to net zero carbon by 2030, if not beyond, if not before. But I want to kind of leave you with an example that's already got there. So this is another Buro Happold project from California, the city of Santa Monica, for their to the municipality, and this scheme is net zero energy, net zero water on site, and is actually now certified LBC ready under the Living Building Challenge as well. So it's a broader sustainable building. There's lots of great videos of this online if you want to go and have a look at it and fly through and understand all about it. But it kind of gives us pinpoints of examples of how, how far you can go with great design, thinking about the location, and there's always something that you can be doing to drive down demand, to enable your project to be ready for net zero carbon, and in some circumstances do it absolutely on site. So I think, it seems like a tall ask, right? Net zero carbon buildings, how on earth are we going to do that? But like you, we're in the business of realizing the impossible. We think that with great collaboration across the supply chain, across the industry, between architects, engineers, clients, and all of the other professionals, we can respond to the challenge. We have to respond to the challenge. There's no plan B. We have to do this, and so we've got to work out how to do it. So I invite you to join the game. Game on. Now's the time to do it. We all need to act. Thank you.
Very insightful. It was one of the most interesting keynote presentations we have had so far. So thank you. Amazing. I can imagine a lot of people have many questions. And David, I think you have one nice question also for David.
Well, I just, first of all, I thought, Duncan, the last slide, or the second last, you were talking about, it's about great collaboration. So it's not just about the architects or the engineers. It's also about, of course, the builder, the manufacturers, products, etc. And that's why I'm actually really excited also to have as one of our discussion partners, Davide Zampini. He's the head of R&D, research and development from Cemex. So it's a worldwide global cement producer. Davide is based in Switzerland. And I mean, they've been making amazing strides in the last years just to lower their carbon footprint. So Davide, I'd like to give you the floor and maybe just ask you maybe to respond to the presentation just now from Duncan and Thomas, and maybe some insight from yourself. What are you hearing from your customers as well?
Well, thank you very much, and really thank you for having me. And really, guys, great presentation. And I think you touched on some very, very important points, no, and some very important key steps that one has to actually take into consideration when actually trying to drive towards net zero carbon. What I like very much, and also emphasized by David, was the fact that some I think almost like when I started in Cemex, I think back in, that was a long time ago, unfortunately, it's 2003. There was a very good study by the World Business Council for Sustainable Development, and they had actually gone out to create this super model to calculate what were the parameters that impacted the CO2 emissions of buildings and structures and whatnot. And it turns out that the single most dominating factor in all of this wasn't like if you selected the right light bulb or selected the right material and whatnot. No. But it's sad to say that one of the biggest impact was that that people who were actually working on the project were not actually collaborating. No, it's very fragmented at times when you actually work on a project. And I think what you guys had mentioned at the end, and how it's very, very important to bring everyone on the project together and align themselves on how to build that project in the way that you want to build it is very key. So I think the communication and how that takes place is very important. So for me, I see that very important. We see that all the time. And linked to that, to some ways, is one of the questions that I had when you guys were presenting was, and this is what we're also confronted with. We get a lot of architects and engineers that actually visit our laboratory because they're kind of curious as to what innovations and what new things are taking place. And what I always discover is that one of the key and fundamental things to be able to design also, and to design a good building with the objectives that we want to, in this particular case, net zero carbon, is you have to have some knowledge, no, of the materials. No? And this is something maybe we can discuss and debate on, but it's like, you know, when people think about concrete, we, you know, think about a gray, very dense material, and basically, you know, give it its connotation. And what we found out is that, you know, when we start to explain to people a little bit about, you know, what are the possibilities of concrete technology, then, you know, doors start to open, no? Because people don't think that you could normally, you know, achieve improve thermal insulation of the concrete by 10 times of the conventional concrete. No? People don't think that, you know, you can design concrete that can be extremely fire resistant, no? And, you know, fire resistance is a big issue. But people don't imagine a lot of things that we can do with concrete. And so I think, you know, and this is not only about concrete. Now, I think in general, I think one of the biggest challenges is to really have that so-called database and knowledge of what's really available out there so that you can actually use those materials, or at least have access to those materials to design the buildings that you wish to design in some way. No? So I think for me, you know, that's also something that more than, you know, I can sit here and you know, boast about, you know, all the great concrete technologies that we have. But for me, it's a fundamental question that I think all of you guys who are, you know, in this meeting should ask yourself. Now, it's like when you think of concrete, you know, think of any material, you know, I would suggest not to just immediately label it and think that, you know, that it is what it is. I think, you know, innovation is taking place and it's going forward. No? And for example, I mean, people are always saying that, you know, we as a cement producer and concrete producer, we're, you know, obviously important emitters of CO2, but there's a lot of things that we're doing also to reduce the emissions that we have in the cement, in let's say, cement manufacturing process. And those emissions, let's say, you know, will soon, you know, go down further and further. I mean, Duncan mentioned a couple of things that, you know, you can do to reduce the CO2 footprint of concretes and cements is by substituting let's say, the main component clinker that's giving CO2 with supplementary cementitious materials like fly ash, slags, and so forth. And there's many other different things that we're doing. No? So,
Davide, just sorry to interrupt there, but I think that's a really great point that you're saying, that, you know, you mentioned the database of materials. I mean, maybe the question then for Duncan and Thomas is, how do you then choose your materials? Is there such a database? Is there a way that you can say, okay, this producer is the right for us because they are actually, yeah, carbon neutral or whatever? How do you choose your products?
It's a really good question. I think so. The starting point at an early stage in a project is generally to look at reference benchmark data from, so for example, in the UK, the Royal Institute of Chartered Surveyors, RICS, produces RICS database, which is probably the most widely used. And those databases plug into software, which allows you to do the optioneering. But ultimately, you need what they call EPDs, which are basically the environmental product declarations from manufacturers. And that's where, you know, if I was specifying a building or setting a brief, you know, be clear about the performance targets I'm trying to get to. You give that to the design team to try and design for that, but they also need to understand the uncertainty around that data. And there is uncertainty around the data, and being very clear about how you specify for procuring that, either through your main contractor or your package contractors, and ultimately through the materials that you're going to be procuring. So it comes back to Davide's point, you know, about exploring innovation, you know, with the supply chain, particularly steel, cement, you know, the kind of the really big ticket items. As an industry, we need to collaborate on innovations in that space, because there's probably only so far that you're going to go with timber. We need to clearly make better use of reusing materials as well. And there will be efficiency gains through off-site prefabrication, design for manufacturing assembly, and so on. Yeah, but at the moment, we need to move as a whole supply chain.
Maybe we can add on that one. So next to what you mentioned, Duncan, we have the Ökobaudat, there is Madasta out there. There's many platforms where you can get material in, and it gives you a good idea. In general, when we review materials, so roughly you can talk about, you know, an office building, maybe 300, 500 different materials that come together. You need to be able to understand really where the big max are. There's those that really makes a difference, and those that are important to look at and not to focus too much on, just because the impact isn't too big. So it's always good to do an LCA and life cycle assessment On many of our projects, we can do it. Sometimes when they go on certification, you do as well. And so it's a good point to do that. But 3 topics I feel for myself are important. One is the access. So it depends on which part of the world you're building. In some markets, there is only certain construction method available. So it doesn't make sense to introduce something necessarily in a duration of a project if you say the industry isn't set to provide it. Sometimes it makes sense to introduce it and to bring it in, but often enough you have a certain schedule on a project that needs to be fulfilled. Second is the knowledge on how to build and what to bring in. That's also on the architecture side, what materials are available and what processes might come in very well. And then the distance. Like Duncan mentioned prefab, it also has to do what is possible as a prefab material and where do we source it. And so that's the other topic. So it's quite a lot of different information that comes together. In our teams, we try to have one person with an overview on materials for a project, especially when you want to do a really good carbon project and carbon consulting. You need to have a person in there that does really look at all the different angles and tries to also consult early on what's possible. And my personal feeling always thinks that it needs to be the right material for the right purpose. We shouldn't have universal solutions, but we should have the right solutions that really help us also on achieving the carbon goals that we presented.
Davide wants to answer that point, and there are many amazing questions from the audience. So maybe after your reply, we can.
No, just quickly on what Thomas just said. No, I mean it's really having the right materials for the right project. No, and I think this is very key. And for example, I'm just stating from our experience. Is that if you don't have the conversation and you don't actually take the time to know what the possibilities are out there, then you miss out. And that conversation is very key because, for example, we as a material supplier, we can, let's say, maybe design the material for having different characteristics. But for example, the solution, for example, we have one great project where, we actually create a facade where this facade made out of concrete could actually cool the building down to let's say down by 6 to 10 degrees from the original air temperature, external air temperature. But that project was only possible because, we tailored a solution that came out of the discussion that we had with the bioclimatic architects, that said, okay, we wanted the building to have these characteristics. They were exposed to the materiality, and then together, you work to actually build the solution, right? Which is a combination of different types of materials that we develop. So that is very important as well. There's not a standard, just pick and choose, and then you have to design for purpose. I think that's very important. What Thomas said.